A very good morning, good afternoon, good evening to all the participants for this NPTEL MOOC course, and the title of the course is Applications of Forecasting Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. And as you know, this is the fifth class for the first week, which will end the week 1, and obviously you will have an assignment based on week 1, all the set of classes. So, in the fourth lecture or class, in the first week we were discussing first a data set X with 12 number of observations, and based on that we found out the mean, sample mode, sample variance, sample median. Then we found out the mean absolute deviation, mean absolute weighted deviation, then mean squared error, mean weighted square error. Then we took another data set Y with same number of data points 12, and we can also find out its mean, median, mode, standard deviation, variance also, but we skipped that. Directly we went to find out the covariance between X and Y, and then we found out the correlation between X and Y. And then we consider one simple example of plotting for weight and height. The data was taken from UCLA data set. Now, based on the ideas of covariance and correlation, we went into considering that for the forecasting concept, we have only one data series. So, hence we need to find out the ideas of covariance and correlation using the concept of autocovariance and autocorrelation, and that will be utilized in details. And we consider the formula in detail by drawing that what we mean by lag, what we mean, and I mentioned verbally what we will be using different type of symbols of M, S later on. Now, we will try to apply that in an example. So, this course is basically covers three broad topics: average techniques and forecasting, multiple linear regression and time series. And this is the ideas of averaging techniques and forecasting which we are discussing. And as I mentioned, again I am repeating, this is week 1, lecture 5. The coverage for this class we'll try to cover. There would be an example or examples. AIC, what is AIC? I will come to that later. Ideas of overfitting and underfitting, autocorrelation functions, Correlogram, mean percentage error, mean absolute percentage error, and all these ideas will be covered accordingly in this flow. Now, let us consider the sixth example, and the example data size is about 56 in number, 56 data points, and I will slowly go and try to solve it accordingly. So, here it is. The data set basically on the first, I will use a different color to mark it as we proceed. So, I will first use the green one and highlight it as we proceed. So, the first column is T, which is the time period starting from 1 to 56. The second column YT, we will always denote the time series of the forecast. The data which we will utilize for forecast is given by Y, the actual data. This is YT starting from 164, which is for the first reading, and the last one is 153. So, second one, as you can see, is 148. I am not putting him highlighting, I am just trying to visually point it out for all the participants who are watching this video lecture. The third one is 152, fourth one is 144, then 155, then 125, and accordingly it goes. And the last one is 153. Now, I need to basically find out the autocorrelation. I will consider a lag corresponding to the concept where we will consider as K as 1. So, we just shift the whole data set by 1 unit. So, the second data point for YT minus 1 is basically 164, which is the first data point for YT. Similarly, it is 148, which shifts by 1 notch lower, 152, 144 goes on till the 55th data is basically now in the place of 56. So, because it has moved by 1. So, and the number 153 is basically taken out from consideration. If it had moved 2 notches considering the lags, In that case, 164 would have gone here. Similarly, 148 would have gone here. That means in place of 152. Then 152 would have gone to 144. That means because k was 2, so it would have moved. So, similarly 130 would have come in place of 119, and the two data set values 119 and 153 would have been taken out of consideration. So, well, that is beside the point. So, let us consider the calculation based on the idea where the movement has been 1. That is why the arrow which you see here is basically the movement. Now, we need to find out the corresponding mean value. So, if I basically find out the mean value, the total sum of yt is 8361. So, the value of 8361 divided by 56, that comes out to be the mean value which we will be utilizing. Now, what does these the fourth column, which I will mark with a different color, red one, what does it mean? It means I am trying to find out the difference between the value and its mean value. So, the first value, which is 14.67, would technically be 164, which is yt, minus the average value, which is 8361 divided by 56. That value comes out to be 14.70, and this is written here. Similarly, if I consider the next value, which is minus 1.30, what it would be? It would be, I will use the same color, but it has been erased, so there should not be any confusion. It would be 148 minus 8361 by 56. That value comes out to be minus 1.30. Similarly, if I go to the last two values which are there in the fourth column, and the values are minus 30.30 and plus 3.47. So, how we will calculate is this. I am going slowly, so please bear with me. The average value remains same, 8361 divided by 56. So, for the value of minus 30.30, it is 130 minus 8361 by 56. That value comes out to be minus 30.30. If I go to the last value again, so which is given as plus 3.70, it will be 119. Oh, sorry, my mistake. I am basically finding out my mistake. I am basically subtracting the values of the second column with the mean value. My mistake, sorry. So, technically, the value of minus 1.43 would be utilizing here, which is, I will again repeat it, please excuse me, 148 minus 8361 divided by 56. Similarly, if I find out the second value, I apologize once again. So, if I use these plus 2.70, so it is 152 minus 8361 divided by 56. Similarly, if I continue for the last two values which are there, and what are the last two values given? Minus 3030 minus plus 3.70, it is this. So, 119 minus 8361 by 56, that value comes out to be minus 3030. And the last value which is there, which would be plus 3.70, it is 153 minus 8361 divided by 56. So technically I am taking the difference between the second set of values, its mean value with the mean value, and then we get the fourth column. So second column correspondingly minus its mean value would give you the corresponding values in the fourth column. So now I come to the fifth column. I'll use a different color so as you continue watching it, so there would not be any confusion. Or later on when we consider, the mean value remains same. Now if I consider, it is basically the third column minus the mean value, and we get the fifth column. So if I am considering, say for example, these two, so it will be 148 minus 8361 divided by 56. That value comes out to be minus 1.30, which is here. Then if I continue the next value, if we say for example this one, 152 minus 8361 by 56, that value comes out to be 2.70, which is given here. Then if I consider, say for example, I'm jumping one value going to this, so 155 minus 8361 by 56 comes out to be plus 5.70 as given here. Similarly, if I consider these two, this is 130 minus 8361 by 56, the value comes out to minus 19.30. This is the value. And finally, if I consider these two, is 119 minus the mean value, which is 8361 by 56, comes out to be minus 30.30, which is here. So once we have done it, we are good to go. So I'll erase all these values. So now I'll use again a different color. Say for example violet. So the sixth column is basically being utilized from the fourth. So square of each corresponding fourth value basically becomes the fifth one. So if I basically have that, I continue accordingly. So if you see the values, say for example I am taking this, so which is minus 5.30, that is whole square, comes out to be 28.13. If I take these two, minus 19.30 whole square comes out to be 372.63. And finally if I take this, plus 3.70 whole square comes out to be 13.66, and the sum of that sixth column is given here, which is important, because if you remember in the formula for autocorrelation and then autocovariance, this value will be utilized, and the value is 21135.84. So if you add up all the sum, now for the other set, so I'll use again a different color, so that continuity of making a differentiation between how we proceed with the colors and the calculation is absolutely clear. So, we will use the light blue one. So, now if I am considering basically the values, so the values would basically I am considering the 7th column, and the 7th column is basically being utilized from the 4th column and the 5th column. So, if you see is basically you are trying to multiply, and here you see the formula multiplication of the y t minus the mean value into y t minus 1 minus the mean value. So, y t minus the mean value is given in the 4th column, which has been marked. Y t minus 1 minus the mean value is given in the 5th column, which is also marked. So, I am trying to multiply 4th and 5th column. So, basically if I consider these two, so is minus 24.30, this star is the multiplication sign, plus 5.70 comes out to be minus 138.44. If I consider these two values, so this is minus 30.30 multiplied by, this is star is a multiplication sign, multiplied by again a minus sign, minus 30.30, which both basically make positive, then the value comes out to be 584.97. And similarly you calculate. The sum of the 7th column is given, which will be utilized, is 8893.59. So, remember the values of the mean has been utilized, which is 8361, I am repeating, divided by 56. Then the 6th column, the 7th column, with the 6th column is the sum of the squares of yt minus mean values, and the 7th column is basically the concept which is coming from the covariance, considering that so called k value is 1. I erase this. We will go to the next slide. Now, what we have shown, these are being illustrated here. So, if I calculate the mean value becomes 8361 divided by 56 is 149.30, which we have been discussing time and again. So, there is no confusion. The value of CIY basically would be given by the corresponding values, and what are these values? 19 point minus 19.16 and so on and so forth. So, if you see, minus 19.16 is basically corresponding to the 7th column, which we will be utilizing to find out the autocorrelation. So, if I add up all of them, the value was 8893.51 divided by 56, that comes out to 158.8, and the autocorrelation is basically the corresponding concept which we will be using. Now, you remember there is n everywhere in the numerator and the denominator. So, n can be taken out, which is 56. So, in the denominator you have the values of the 7th column, which was basically multiplied values of yt minus mean value multiplied by yt minus 1 minus mean value, and that was 158.8. So, 56 would be cancelled. So, we will put 889.351 in the numerator, and in the denominator, if you remember, we will take the values of so called standard deviation of x into standard deviation of x, which is the so called the concept of the variance of itself. So, the variance was basically being calculated from the 6th column, and the sum was 2113.58. So, it basically becomes 2113.58 once you find out. The autocorrelation for 1 lakh value comes out to be plus 0.421. Now, similarly, which is important, similarly we can find out the covariance based on lakh for 2, lakh for 3, and it can continue. And once you find out, you can correspondingly find out the autocorrelation for k is equal to 2. So, both are same. So, I am just using a different color because it is for the autocorrelation. Similarly, you can find it for 3 also. This is 3. So, you can find out for 3. So, the values where its maximum, as you can understand, if the relationship is highest, that is what is basically help us in trying to forecast to the maximum possible extent. That means, we need to basically minimize so called the error based on forecasting. So, together with autocorrelation, add lags 1, 2, 3, 4, everything basically gives us the idea of autocorrelation function or ACF. So, ACF plots can be done and it will give you a lot of information. Rather than scanning a list of numbers, it is much easier to plot the autocorrelation function against this lag. So, for k is equal to 1, I basically have the autocorrelation function value. For K2, K3 correspondingly. So, I try to find out for which it is the highest. Such a plot is basically called the correlogram and helps us in visualizing the autocorrelation function very nicely. Rather than values, if you have a pictorial diagram, it will be very helpful. Now, for this problem, rather than finding out these values of autocorrelation for each individually, for lags of 2, 3, 4, rather than that, I have plotted it. First, I found out and plotted it. And if you remember, for k is equal to 1, it was coming out to be about 0.42 and this is the value plus. Similarly, for lag k is equal to 2, I will use a color different. For 2, you see the value comes out to be very low. Very interestingly, the values of K3, 4, 5, 6, 7, 8 all are negative and it is maximum is negative for the 6th value. Very interestingly, I am giving some information for autocorrelation for the 9th lag is almost 0. So, there is no relationship. So, this is basically for the 9th one. So, 9th, 10th, 11th. So, for the 10th, 11th, 12th, 13th, 14th. And then again, it goes on for 15th, 16th, 17th, 18th, 19th, 20th. And very interestingly, this 15, 16, 17, 18, 19, 20. So, that means 1, 2, 3, 4, 5, 6, 6 of them. And here 3, 4, 5, 6, 7, 8. Again, you have basically 6 of them. So, this is basically being repeated, which means that from here you can find out the maximum information is coming from the 12th value. That means, there is 1 year cycle based on which you can find out which lag value gives the highest autocorrelations. Need not be 12, it can be any other value, but autocorrelation functions using the correlogram would give you lot of information to plot. So, here just for information, lag is being plotted along the x axis and autocorrelation function is being plotted along the y axis. And remember, the value of autocorrelation or correlation coefficient is always between -1 and +1. So, the graph is basically like this. So, if you see very interestingly, if I remove everything here, see if I have it. So, the graph is basically like this. A sinusoidal curve. So, this is basically these two are just giving you the information, they are replicating them after a cycle of 1 year. And this one, if I find out, this will be repeated, this has been done, so it will be done here. So, 1 year and it will continue. And if I plot the data So, if I am, and there can be different ways of plotting the data. I am just giving an example. If I plot so called the errors, and if I plot the errors for one data set, where year wise we have so called the values, either the data set or the errors. Very interestingly, you see it. I am only giving you pictorially. So, this data set, if you consider this part, very interestingly, is being almost repeated. So, if you see, there is a gap of about 1 year. This I am doing without any calculation. I am just giving my observation. And if I consider the trough, the lowest value, I will just mark with the green one. See, 1990 to here, 1993. Similarly for 1994, 1995, again 1 year repetition. If I consider the peak, about 3/4 gone for 1991. Here also about 3/4 gone for 1991. Here also about 3/4 gone for 1991. Even for 1994, there are two peaks, but I will consider this one. Again, it will be repeated. So, generally, there is a so-called characteristics being portrayed pictorially with a difference of 1 year. So, we will consider these ideas, concept using cyclicity concept, using the concept of seasonality, and also along with that we will consider the concept of variability, and obviously mean value or trend value would be there. So, with this I will end the 5th lecture for week 1 and consider more examples accordingly. Thank you very much and have a nice day.